I'd say we start, and then everyone else can just join whenever they are ready. So welcome everyone to this ECOP Wednesday webinar. I'm Alexandra Hahn and I will moderate today's session. So before we start, I want to go over some housekeeping rules so we're all on the same page. So please make sure your name is clearly entered. So if you ask questions, we know who you are. Keep your microphone muted unless you are talking, and raise your hand before you speak. You can also use the chat function if you feel uncomfortable switching on your microphone, and make comments there and ask questions, and I will read them out later. And always be respectful and use appropriate language. We also will stop recording after the talk, so you can ask whatever question and feel comfortable. And then a few words about the ECOP network that is hosting today's event. This was established by the EMB Young Ambassadors and the EMB Secretariat, and it's for early career ocean professionals at EMB member organizations. And we want to give early careers an opportunity to network and meet peers across Europe, and also gain a voice at the EMB level. And for this, we have different events, and this seminar series is one of them. And with that, I already come to today's speaker. She is a postdoctoral fellow at the University of Bergen in Norway, and her name is Aiste, where she's doing deep sea mining policy research. And before I say too much, I want to hand it over to her. She's also part of our network. This is why we're especially excited to have her talk about her research today. So give it to you, Aiste.
Thank you, Alexandra. Hello, everyone. So let me share my screen with you. Just one moment. Here we go. And let's start with the title. So, Deep Sea Mining Policy Process in Norway. I'm working with on it with my colleague Laura Drivdal, who is also from University of Bergen. And in short, this title basically tells you mitigate it till you make it. That's basically the outcome of our research in short. But let's start from the beginning. So a little bit of background, why deep sea mining is even a topic on the table today and, in the past months and years. I think one good way of seeing it is just to think it about this all blue growth aspirations in general, so that the idea that we should grow ocean industries and, have more things happening in the ocean. So first quote comes from Virginijus Sinkevičius, who is the EU Commissioner for Oceans, Environment and Fisheries. And he says, we would like the new industrial, we would like this transition to a sustainable blue economy to be like the new industrial revolution. So it gives you a sense how exciting it is, at least for politicians and, for scientists. Industrial revolution might mean quite something else. And the other quote that you see below comes from the Blue Opportunities document, which is a document that came out in Norway about basically what strategy the government in Norway has. And this is a short quote which says, Norway would like and will maintain its position as a world leader in sound ocean management and will promote value creation from the ocean. So these two quotes, of course, they are plucked from a context and given to you, and they're very short, but they should give you a sense what it is all about. And deep sea mining is one of the things, or one of the industry ideas that are currently entertained in the government here. And I think one important thing would be, before we move on, is for you to think why even doing research, for example, on policy processes is important, and why findings from such work that we did would be important. So for policymakers, there are a lot of topics and issues that they need to deal with every day. And when the Norwegian parliament voted that they should open Norwegian continental shelf for deep sea mining, exploration and exploitation, they might as well on the same day have voted for many other things, including, for example, reproductive health. It means for politicians, it's important to get very concrete information from experts and scientists. And you know, they will vote for many other things. So there's very short window of, you know, informing them about various issues. And what also you need to keep in mind when looking at this slide is that at the end of the day, it's any of these decisions in policy are political decisions. So even though, for example, often in Norway, it's said that, you know, opening of areas is science informed, it's based on knowledge, it's based on expert advice. You need to keep in mind that decision is political decision. No scientist said, you know, has a right to vote even for opening these areas. And a little bit of methodology information. So I work with text as data, and text as data means that you kind of browse through many different texts and look for patterns in them. So it's a little bit like doing quantitative research, I guess. You basically look for specific data points, define those data points, and look what patterns they show you. That's in very short. So deep sea mining policy context in Norway. There are many things that happened, and I think this just gives you a kind of a short summary that in 2017, the government said, okay, we should consider it. This might be interesting, this might be profitable, this might be, you know, a new adventure after oil. Of course, many things happened before 2017. You know, in 70s, the discovery of deep sea vents meant that it also, how to say, was the start of interest, economic interest, thinking we might want, or we could be, you know, extracting minerals from those vents. So, you know, historical things are there in the context as well, but fast forward, moving on to recent things that happened here in Norway. So the government commissioned studies that were used to produce an impact assessment that came out in October 2022. And that impact assessment basically informed the government vote that happened actually just last month. And here we are today talking about this. So a little bit of background where this is happening and like how big this is. What you see here is from Mariano program. So Mariano is this big government-funded program that collects ocean data to inform basically government decisions, to inform ocean management here in Norway. If you have time and interest, you can go to their page and explore it. It's really great. And what you see in the map is basically areas that will be open. There is an inset smaller map, and the purple areas are basically the planned areas for opening. They are around 300,000 square kilometers, so it's almost the size of Norway itself. And yeah, you see that some of here, what you see is just basically bathymetry data. So you see that the coast is well probably explored compared to the other areas. But I mean, the boomerang that you see in the map, I don't know if you see my mouse, this boomerang is basically the areas of interest, because these are places with sea vents which potentially have minerals. And this is just another map for you to see the continental shelf. So the most outer kind of line shows you the Norwegian continental shelf, and there's this boomerang again. Ridge, which is like a trench, and you know there are probably also mountains around it, because yeah, there are steep areas. So if you ever went on hiking in mountains, you can imagine how it looks there in the deep sea. And the questions in focus that we had several questions for this research that we did. Main question was basically, since the government commissioned these reports to write up this impact assessment that will inform or has informed the parliament vote, how these reports were basically translated into this impact assessment. So how was the expert and scientific knowledge taken from the reports and put into impact assessment, which in short just means how science becomes policy. And why this question? Because I think in general it's important. You might have your own answer why it's important, but it's important because you kind of have decisions for the future that are crucial. So let's say if you imagine someone who decided that we should start drilling for oil, you know, years back, how those decisions were made kind of tells you how things are progressing. So if we care about the future, attention to policymaking is one of the kind of key things that can help to inform how decisions are made and how should they be questioned, can they be made better? And a little bit about this. So what we did, we worked with document analysis, right? The main document that we worked with is impact assessment, which has around 40,000 words. It's around 120 pages. The full sample, of course, includes all the other reports that were commissioned for this impact assessment. So there were 6 expert reports that provided kind of basic knowledge, what they call basic information and understanding that they have here. And then there were 3 other reports that were commissioned, which it says to clarify that basic knowledge. And then you have like kind of all this process that comes from one group of documents and experts to the other to finally to impact assessment. And then, of course, when you do this kind of research, you have also a lot of field notes, which involve many things, including how you analyze data, how you decide what is a pattern, how you decide what is a data point. And the final thing, what you see on the slide, it says data points in this presentation. I say data points, they are not really data points. They are pieces of text that are gathered together and make up certain pattern. So it's not really accurate to say these are data points, but just for clarity, if some of you work with, you know, data points as such, numerical points, you know, samples, for me, these are data points. So what I will show you today basically comes from 257 of these points that were gathered into 2 broad patterns. And the document in focus is the impact assessment, as already mentioned. And if you already are tired of all this talking, I can tell you that there are 2 broad kind of themes that interact with each other. So there is a theme or pattern of things that are said about how this can help for transition, including energy transition. So this is one big part of rationalizing why this is needed in the document itself. And the other quite big, how to say, group of text or statements and things that appear in the document are about uncertainty. So there are a lot of uncertainties, of course, in basic knowledge of what is there. And let's move on. So here, let's imagine you flip pages with me of this document, and I'll take you through different quotes that show different things. And we're just like flipping from page to page and just reading what there is. So there are these raw data kind of quotes points, but I just highlight what is important so you can follow that. And let's start with this energy transition. So there are a lot of things said about energy transition there. They're not based on the reports actually commissioned. Often it's mentioned that, you know, World Bank issued this report or the Environmental Energy Agency issued another report, and that these things show that there is a need basically for energy transition and there is a need for minerals. So on page 3, what we see, there's also kind of this big summary of what is hoped with all this. And it says just, there is a hope that will become, deep sea mining can or will become an important industry in Norway. It is hoped that it can provide a global access to minerals through exploration and exploitation. And of course, there is I mentioned that the degree of environmental impact will be acceptable. The word acceptable actually is never operationalized and never explained. So this is just pay attention that there is a language that says something that not necessarily means something in reality. And let's skip more. So again, keep in mind, why is this important? Is because this is one of the key documents that the Parliament vote was based on. Let's go to all these now uncertainties. There are a lot of uncertainties, and the document is quite open about it. And it says there are great uncertainties relating, to the minerals. The minerals actually are, in technical terms, an unexplored resource. It means they do not they know they are there. They do not know how much, and it's before even starting talking about economic viability of any mineral resource. So again, they're not sure about that. They say that it's not sure what are the possible economic and societal effects. But what seems to be clear, they say, is that there can be a potentially great value for society if areas are opened for exploration and exploitation, and if significant resources of valuable minerals are found there and extracted. But then if you go a bit further, it says, actually, in the same paragraph, it says that there is a great uncertainty related to the extent of resources, profitability, and possible extraction methods. So you see how this kind of uncomfortable uncertainty is evolving. And we skip further, and it says today there is a great uncertainty both related to the extent of profitable seabed minerals on the continental shelf here in Norway. It's not clear what technological solutions are needed. It's not clear where the processing would happen. And it says just the uncertainty is so great that no good scientific basis has been found on which to base the analysis of scenarios even for these things. And we flip further, and it says impact assessment is a tool for predicting effects, and it's itself fraught with uncertainty. So they say that, a lot of things, knowledge is very sparse, assumptions have been made. And then this is a little thing that I wanted to show you. So it's quantitative text analysis. So for what you saw now so far, it's qualitative text analysis, where you basically manually read everything, connect everything to the other reports that exist, check everything. And then there's a way to also see, often, for example, to play with your own kind of perception to see maybe you have missed something, or maybe you haven't seen something that's stronger, maybe that there is a stronger pattern. So I often go to this quantitative text analysis tool, which is called Voyant Tools. You can go there actually and upload any of your text or your favorite book chapter, and it gives you basically a quantitative assessment of various words. You can, produce word clouds. But what you see here is basically this one line is one document, which is the impact assessment. And I just picked up all the words that are synonymous or associated with the word uncertainty. So you see possible, presumed, something is unknown, uncertain, estimates, assumed, limits, expected, all these words. You just take the root. You can tell the tool that you just want the root of the word. So then it kind of captures everything. It means if it says uncertain, uncertainty, estimate, estimation, estimates, it will capture all of these. And basically what you see here is that there are 368 of these kind of words in a document that is 119 pages. It's just to play to see, how strong this is, and this is just for comparison for you to see. On below you see 5 most frequent words in the whole document, so you can kind of compare how these uncertainty words are sprinkled. But again, it might not be self-intuitive and not like really intuitive. It's just one line is one document, and basically the bubbles give you the frequency of these words along this document. So it's an interesting way to just to look into things. But let's move on. So there's a way that there are a lot of uncertainties, of course, but there's a way to formalize these into something that kind of is more concrete. And what I am showing you here is a table on page 107, and basically gives you a list of impacts that are expected. And then they say in column 2, the environment where it will happen, in column 3, the impact, how it will be, and the assessment. And basically, this is just a snippet of a table for you to see how all these uncertainties in the whole document are kind of put into one table. So again, remember, I'm giving you kind of a pieces of raw stuff that gather into some kind of pattern, but just for you to feel what these pieces of information kind of say. So in this case, there is a lot of interest in active deep sea vent mining here in Norway. And this part of the table talks about physical removal of inactive sulfide deposits, which basically are structures of deep sea vents. So the environment is the benthic community on those vents, and the impact level says small. Why is it small? Because there were some kind of mistranslations in different reports. The report that talks about benthos was actually produced by University of Bergen. There is a deep sea research center here, which you can find on any search engine that you use, and you can go and see what works they do. So there was a group of scientists from this deep sea research center that were kind of hired to produce report on this specific thing. But then that report, of course, was translated or clarified in another round of reports. And then what ended up in the impact assessment is something quite strange that says that, you know, the impact will be small because there's a rapid recovery. This rapid recovery, if you trace it back where it comes from another document that talks about proxy studies in shallow waters on unrelated environment, but they say, well, there's a rapid recovery there, so we can just kind of generalize it. And of course, they actually are also quite open because they say, you know, the affected area constitutes a small proportion of the seabed with an assumed corresponding soft bottom fauna, which is assumed, so it's not really clear. We don't know what's the fauna there, but and it says no, that the impact level small applies if the fauna at the inactive sources consists of the soft bottom fauna that does not differ from surrounding areas. And of course, there's like a little asterisk that also tells you, you know, the university report says that there is no way there is distinction between active and inactive deposits is not entirely clear. It's very problematic, and the fauna is also it's not studied, it's unknown, but you already have a table which kind of formalizes the knowledge and already puts small in the column, so it becomes a fact in a way. But what you saw so far presumably gives quite a lot of discomfort for the people who work on the impact assessment. So all this kind of discomfort with this uncertainty, there's some kind of uncomfortable tension, right? And there is a way to release it, how to release it. So impact assessment often has, as a document, it often has a quite big section on mitigation. So we can mitigate things, right? There are potential impacts and we will mitigate them possibly. It makes a lot of sense in terrestrial activities or developments, but in short sense, there are 4 things of mitigation where you either avoid doing something, you minimize through doing less or doing differently. You can remediate and offset. I will give you a short example. If you cut the forest, you can replant the trees and you can grow another forest. In the deep sea, it doesn't work like that. If you heard anything about, for example, international seabed, so international seabed has these kind of potato-sized nodules that are the interest for possible mining. There is an experiment that started 2-3 years ago where they put ceramic balls to imitate these nodules, but you can imagine that a ceramic ball doesn't imitate an integral part of habitat, which, you know, is covered with specific material, which attracts specific, you know, bacteria, which then holds the whole food web on its shoulder. So there are, how to say, ways where people think we could maybe reverse it, or we could put artificial structures there that could imitate the role of these ecosystems and their components, but it's not like that, and it's tricky. And of course, the impact assessment is quite open, that it says for most impact, it says it's possible to take measures, and it also says even that the mitigation measures can reduce environmental impacts, which in turn can actually contribute to achieving sustainability goals, which might sound very strange to you at this moment, but let's move on. It also says that mitigation measures are characterized themselves by great uncertainty, and it openly says that proposed mitigation measures in the document are of generic nature. So what happens here? And we sat down and we started thinking, what are these patterns showing us? What is this big thing about uncertainty? What is this big thing about yearning for certainty? And we kind of thought that this tension about uncertainties and this need for certainty is dealt through mitigization. So the technical purpose of mitigization is no longer technical purpose as it is in impact assessment, because the technical purpose is to deal with impacts of environmental impacts, basically, right? What happens here is this semantic mitigization where everything becomes a topic or question for mitigation. So if you will, you can imagine a group of people behind this impact assessment who sat together and said, okay, these uncertainties are too large. We need to mitigate the whole document itself so that it's acceptable enough for the parliament to vote and to progress with this. And you might think, like, why it even makes sense to give this new word, and what is this like even a finding about? And I think just in simple terms, if you talk about, for example, how plants use sunlight to do something, if you don't give the word, which is photosynthesis, you can describe that process very elaborately, but if there's no word to describe it, you still have a missing kind of piece of information or understanding of it. So it's just kind of an analogy for you to understand that in work that I do, when you kind of explore these topics in the text and come to an end of your analysis, you need to think of what you saw and how you describe it. What is this word that best represents what happened here? So we decided that mitigation was taking out of context and used in creative ways to deal with all these uncertainties. And that's why we kind of give you this word of mitigization, which allows you to get a feeling that there's something else going on. So just to recap, mitigization is dealing with uncertainties, which is the actually technical purpose of mitigation itself, right? But mitigization goes much further. So everything becomes a question of mitigation. So you are dealing with, the impact of impact assessment itself and trying to make it, again, acceptable enough for political vote to happen. And of course, there's a whole mitigization of the opening process, because by mitigating all these processes, you are, trying to get a positive progress of deep sea mining industry itself. So again, I failed probably to mention in the very beginning that the ministry who is in charge of this is the Ministry of Oil and Energy. So the ministry itself is basically has an interest to make this happen. And because it wants to make this happen, it tries to mitigate the whole process. I think it's very important also to think what it means in terms of when scientific input is used as a tool that is not informing the process itself, but scientific and expert input was rather used to kind of enable already predefined hopes and goals of the ministry and other bodies that were associated with it. So for the ministry, it's a positive thing. It's a new industry, potentially could be repeating, the rush and the excitement of oil history in Norway. So for them, it's a question that needs to progress and needs to happen, and they're working towards that. But in terms of science, it becomes quite strange and probably disheartening for many scientists that their input and their expertise is kind of irrelevant in a way, because I mean, the decision was made already. The decision was to open, right? And saying that, you know, we're gathering all this expert knowledge along the way to inform the process is slightly misleading, because it's not really informing the process, it's enabling the process. And for the purpose of this webinar, I think it's also interesting to think in terms of what it means when, you know, for the whole science policy interface. And you can imagine many different things happening out of this, and many, for example, some scientists might just become disillusioned with it and not really interested in science policy interface at all, and not interested in participating in any kind of these kind of things. But then there's also a problem if we have good scientists and good, you know, experts with highly valuable baggage of knowledge who just, you know, become disinterested and just lose any kind of hope, and then just start doing their research. But I think the most attention should be actually to find ways how we could nurture these the science policy interface, and how could we motivate people to really participate rather than to just you know, do things that make people disengage. That's it for me. Thank you. And I hope you have many questions that I'm looking forward to hear. Back to you, Alexandra.
Yeah, thank you. And I think we can stop the recording now.